Hello everyone, this is Team 21. My name is Yan. I'll be the first one to introduce our project. Our topic is about image style transfer. There are basically 4 parts, and I'll introduce the first 2 ones. Okay, let's get started. The first one, what is style transfer? Style transfer is mapping images into another class. As you can see in the sample image, it turns a photograph of the campus of Stanford University into a painting-like style. And also, there are more sample images, which turns the Golden State Bridge into the desired target style, maybe a style from a portrait or other objects. And also, it can turn the portrait into another style. So we want to make our own trial. This is me. We turned me into another style and another style. Soon we realize a problem. We don't know much about art, so we can't tell how good the model is. So we want to change to something more interesting and interpretable. Here comes the second part. Why do we choose this topic? It's been a long time since we want to turn our friends into animals. Soon, the animal give us the opportunity to do so. As you can see, the model can turn cats into tigers. So we think the model is also supposed to turn human into animals. So we make our own trial. The first image is our friend, and we successfully turn him into several kinds of animals, and most of them work pretty well. So we want to implement with our own dataset. There are basically 2 parts, the human dataset and dog dataset. Human dataset, we use the STLAB A dataset, which contains human faces. And for the dog dataset, we use Stanford Dogs dataset, which contains more than 200,000 different branches of dogs. This is our initial works. And this is our model, which will be explained in more detail by my teammate. These are some of our results. As you can see in the picture, underfitting happens a lot. There are basically 2 reasons. The first one is we didn't train it enough. We only train less than 100 epochs, and it needs maybe at least 200 epochs. And also, the dog dataset contains not only dog faces, but also the dog bodies or other background. So these may confuse the model, confuse the network. So we need a more proper dataset. Then we find this dataset, the cartoon set 10K, which contains random cartoon faces with pure background. And this helps a lot to train the model.
We implemented a cycle GAN to do our job. The reason we use a cycle GAN is because cycle GAN takes unpaired data. We don't have paired data, and pair them up randomly makes no sense. We use 8,000 cartoon faces and 8,000 human faces as our training data. The network we use has two exactly same generators and 2 exactly same discriminators. The generator has net rest block for downsampling and 3 upsampling blocks. The interesting part is cycle GAN has 2 losses. One of them is called GAN loss, which means how the output looks like the cartoon, and the other loss is called cycle consistency loss. This indicates the quality of the output reconstruction. This controls how much features in the input can be preserved to the output. In our GAN, we set GAN loss weight to be 2 and cycle consistent loss to be 1, which means making it cartoonized is 2 times more important than preserve the original features. And we took 64 by 64 image as input and 64 by 64 as output. The training time per epoch takes around 20 minutes on V100 GPU, and we train 100 epoch, and this is our result. We can see the original image has transferred to a cartoon style in some way. One of the problems is our cartoon dataset has white background. The quality of the white background human faces is much better than those with other background. We input our pictures into the generator, and some of them has bad results. The other problem is the 64 by 64 image is so blurred. We can't see the eyes and noses from the output image. And we take another shot on increasing the size of the input. And to reduce the complexity, we use only 3 downsampling blocks and 3 upsampling blocks. The training time takes around 30 minutes per epoch, and this is our result. You can see from the output image looks better than 64 by 64, and the eyes and lips and teeth looks very like cartoon, but still some of them generate some failure.
Okay, this is the conclusion of our project. We first read relevant research papers and learn codes on GitHub, and then do our own implementation. We find problems and fix them, and adjust our model structure and tune the parameters. There are basically some of the future works. We can find some more more data model structures and use advanced techniques to avoid overfitting and make the model more robust. Thanks for listening. And finally, we want to say thank you to Amazon Educate for providing support for cloud computing resources. Thank you.